All right, let's jump right in. Today, we're going to tackle something that's absolutely fundamental to networking in AWS, but honestly can be a little confusing at first, the VPC route table. By the time we're done here, you'll see exactly how your cloud network thinks.
So think about this for a second. You've got all this stuff running in your virtual private cloud. Servers, applications, you name it. When one of those servers wants to send out a piece of data, how does it actually know which path to take? How does it get to the internet? Or maybe back to your own office, right? What's the map? What's the GPS for all that traffic?
Okay, let's get into it. The answer to that question all comes down to one thing, what I like to call the VPC's traffic controller. This is the component that's in charge of directing every single packet of data to exactly where it needs to go.
And that's really all it is. A VPC route table is basically just a rule book, a set of simple instructions. Each one of those rules is called a route, and its entire job is to look at a piece of data and say, okay, you go that way. Every single packet that leaves a resource has to check this table for directions.
So if the route table is the whole rulebook, what's written on a single page? What actually makes up one of these routes? Well, it's actually super simple. It really just boils down to two key ingredients.
Yeah, every single route has to answer two basic questions. First, where are you trying to go? That's the destination. And second, how are you going to get there? That's the target. You can just think of it as the address and the exit ramp.
And this right here, this is probably the most common, most important route you'll ever see. The destination, 0.0.0.0/0, that's just a fancy way of saying anywhere and everywhere else. Basically the internet. And the target, an internet gateway, or IGW. This one little rule is literally the on-ramp to the entire public internet for your network.
Okay, now for the cool part. Let's see how we can use these simple rules to build really secure zones in our network. This is where the magic really happens.
So first things first, there's one rule that comes built in with every single route table, and you can't touch it. It's the local route. Basically, it says anything trying to get to another address inside this VPC, well, it can just go there directly. This is the rule that lets all your internal stuff talk to each other without any extra setup. It just works. Okay, now check this out. This is a classic public subnet route table. You've got that local route we just talked about, so everything inside can chat, but then you have this second rule, the one sending all that internet-bound traffic, the 0.0.0.0/0, straight to the internet gateway. That's it. That one line is what flips the switch and makes a subnet public.
And boom, this is what's so powerful. Look closely. The only thing that changed here was the target. Instead of an internet gateway, we're now pointing to a NAT gateway. Now, what a NAT gateway does is let your servers reach out to the internet, say for software updates, but it slams the door on anything from the internet trying to get in. By changing one word, one target, we've gone from a public space to a secure, private vault.
And this is so important. This isn't just some abstract networking concept. This is how you protect your crown jewels, your databases, your secret backend services. You put your public-facing web servers in that public subnet, but the really sensitive stuff, it lives here, in the private subnet, totally shielded from the outside world. It's a fundamental security pattern.
So, a quick note on this. When you first set up a VPC, AWS gives you a main route table. Anything new you create just gets attached to it by default. But, and this is a big but, the best practice is to always create your own custom route tables. Why? Because it forces you to be explicit. You decide exactly what can talk to what. It makes your security posture way clearer and much harder to mess up by accident.
All right, so far so good. But what happens if a piece of traffic could technically match more than one rule in the table? How does the router decide which one to follow? Well, thankfully, there's no guessing involved. There's a very clear rule of the road.
So let's imagine a scenario. You've got that general rule for all internet traffic, but you also add a super specific rule for traffic that needs to go to a partner's network over a special connection. So what happens when a server sends a packet to that partner? It matches both rules. Which one gets priority?
The answer is a simple and elegant rule: longest prefix match. All that means is the router always chooses the most specific route it can find. In a networking, most specific just means the one with the longer subnet mask. The bigger number after the slash.
So the router's decision process is basically this simple two-step. First, it looks at the destination IP and finds every single route in the table that could possibly be a match. Then, out of that group of matches,
It just picks the one with the longest, most specific prefix. That's the winner, every time.
Okay, let's see it in action. Say a packet is headed to the IP address 10.0.10.5. Does it match the top rule, 10.0.0.0/16? Yep, but wait, it also matches the bottom rule, 10.0.10.0/24. Since 24 is a longer prefix than 16, it's more specific. So the router says, aha, this one's the winner. It completely ignores the more general rule and sends the traffic straight to that VPC peering connection.
All right, we've talked a lot about getting to the internet. But route tables are so much more powerful than that. They're the key to connecting your VPC to, well, pretty much anything. So for this last part, let's look beyond just the internet.
Yeah, that same super simple concept, destination and target, is all you need to build some seriously complex and powerful networks. You can link VPCs together, you can create a secure bridge back to your own office data center, you can even talk to AWS services like S3 without ever sending a packet over the public internet.
I love this slide because it's basically a menu of advanced networking options. Need to connect to another VPC? Okay, your target is a VPC peering connection. Want to hook up to your corporate data center with a VPN? Your target is a virtual private gateway. Need private access to S3? That'll be a VPC endpoint. Each specific goal has its own special type of target, and you can figure it all right here in the route table.
All right, let's wrap this up with the key things to remember. 1. Route tables are your VPC's brain, its traffic controller. 2. A single route, just one line, is what determines if a subnet is public or private. That's a huge security concept. 3. When in doubt, the most specific route always wins. That's the longest prefix match rule. And 4. Please always use custom route tables. It'll make your life easier and your network safer.
So I want to leave you with this final thought. Your route tables aren't just technical settings. They are literally the front door to your network. They're the locks, the keys, the secret passages. So take a look at yours and ask yourself, who have I given the keys to? Thanks so much for tuning in.